3 rank-based non-parametric tests. Three rank-based non-parametric tests. Learn 3 parametric tests. Note the names. You have to remember the names. The test 1 and 1 prime have the same purpose. 2 and 2 prime, 3 and 3 prime serve the same purpose. 1, 2, 3 are parametric tests. Tests for good measurements. Good measurement means basically interval level, at least interval or ratio, and normally distributed population. And 1 prime, 2 prime, 3 prime are rank based. They use ranks. Ranks are numbers 1, 2, 3, 4, 5, 6 to n, like this. All data are given serial numbers. These tests use only these serial numbers. They are called non-parametric tests, not a very good measurement test. They are tests for not very good measurements, not very good populations. The first pair of tests are independent samples t-tests and Wilcoxon rank sum tests. They compare two means, two tail, one tail, right tail, left tail possible. The same HOHA. Independent samples t-test uses t-distribution with degrees of freedom n1 minus 1 plus n2 minus 1. Therefore, n1 plus n2 minus 2. And for a two-tail test, critical value is on both sides. The same distance, at the same distance from 0 in the middle. Therefore, in mentioning critical values, put plus and minus. Plus on the right, minus on the left. And Wilcoxon rank sum test uses normal probability distribution. Therefore, see table, see formula. Or the original statistic is W. W is the sum or ranks of one sample. And you note that W is normally distributed with mean, this formula, mu of W, and standard deviation, this formula. And in independent samples t-test, this formula is used for the case sigma 1 square and sigma 2 square are equal. If we can believe that sigma 1 square and sigma 2 square are equal. And example data are given below. Midterm scores. Think about midterm scores of two independent samples M and F. There are 6 students each, altogether 12 students. So sample size of sample 1 and 1 is 6. Size of sample 2 and 2 is 6 also, and 1 plus n2 is 12. And to use the same data set in Wilcoxon rank sum test, we have to rank the data first. Usually you can give rank numbers from smallest to largest, from ranks 1 to rank n. Smallest is 8, so rank 1. And the second smallest among those 12 data is 10, so give rank 2. You change number 10 to 2. The third smallest is 14, you give rank 3, and so on. Rank 4, 5, 6, 7, 8, 9, 10, 11, 12, highest 34 marks. After that, rank sum of sample m. 1 plus 3 plus 6 plus 9 plus 10 plus 11. This is sample 1 rank sum. For a two-tailed test, you can use sample 1 rank sum or sample 2 rank sum. Either one is called W. W is rank sum of one suitable sample. Sample 2 rank sum is 2 plus 4 plus 6 plus 7 plus 8 plus 12. This is, you can take this rank sum as W also. Exercise 1. A math instructor has 2 classes in advanced calculus. There are 6 students in class 1 and 6 students in class 2. The instructor uses a programmed textbook in class 1 and a conventional textbook in class 2. At the end of the semester, in order to determine if the type of text employed influences student performance, he ranks the 12 students in the 2 classes with respect to math ability. The rankings of the students in the 2 classes are as follows. Class 1, class 2, and assume the lower the rank, the better the student. Lower the rank, the better student. Okay, read again. So this is, there are 2 classes, therefore they are independent samples, totally 12 students, independent samples, and type of text. Type of text is one variable. Okay, we say we write X because X influences, X affects performance Y. Y depends on X, X affects Y. This way of viewing relationship. So type of text, 2 types, programmed, conventional. So 2 types. For each student, they recorded 2 variables. The first one is type of text, or you can say class label, okay, 1 or 2. Okay, the first variable, nominal level, 2 values. The variable name is type of text. Values are programmed textbook and conventional textbook. Another variable is performance, measured at ordinal level, ranks, ordinal level. And so here you note the notation. N1 is 6 students, N2 is 6 students, N is 12, totally 12 students. So Y depends on X. That means if you change type of text, student performance will change. Student performance will change. Student performance is measured at ranks. Therefore, you compare means. conventional HO equal conventional textbook, mean performance, and program textbook. Program textbook class performance, conventional textbook class performance, the same or not. Or you can write mean score of class number 1, mean score of class number 2, the same or not. You change textbook, then score, rank, score rank will change or not. This way of viewing. So alternate hypothesis not equal. Means scores, mean ranks are the same, not the same. For two classes or for two types of textbooks. So critical value, what is ranks, ordinal level, ordinal. If you use ordinal, you must use non-parametric test. Therefore, Wilcoxon, not W. So critical value, you must go and see Z table. You must remember 2 tilde test plus minus and 2 tilde 0.05. Okay, 0.05. So you draw the sketch, shake the tails, 0 in the middle. You go to the table and read. Okay, what are the positive critical value and negative critical values? These two areas combined is alpha 0.05. Therefore, only one area is 0.025. Therefore, the middle area is 0.5 minus 0.025, 0.475. Okay, if the area between 0 and positive critical value is 0.4750, then what is this critical value? You have to go and read at C table. Look for the area 0.475 here. 475, therefore 1.9 column 0.06, therefore this is 1.96 and this area will be 0.475 and the tail area will be 0.025. Now the positive critical value is 1.96. The left and right are symmetric, therefore the areas are the same on the left and right. The negative critical value is negative 1.96. So write 3C is equal to plus and minus 1.96. There are two critical values. Farther than these values from 0 will be rejection region. Note this. So farther than 0, farther than these points from 0, that means all z scores more than 1.96 and all z scores less than negative 1.96. These z scores are called non-rejection region. Rejection region. The middle areas are non-rejection regions. After that, test statistic. The data are ranks already, and the test is 2 tilde test. Therefore, we can use class 1 W or class 2 W. If you take class 1 W, W is the sum of ranks. In class 1, this is 1 plus 3 plus 5 plus 7. So we compute 16, 27, 37. W is 37. If we take W from class 2, W will be the sum sigma of length R 2 for class 2. This is 2 plus 4 plus 6 plus 12, 12 plus 8, 20, 29, 29 plus 12, 41. You can use either one. And what is important is if you choose W from sample 1, the formula is W minus N1 times N1 plus N2 plus 1 over 2 and divided by square root of N1, N2, N1 plus N2 plus 1 divided by 12. So compute 37 minus 6 times. This 6 is from class 1. 6 plus 6 plus 1, 13 over 2, square root of 6 times 13 over 12. Yeah. After that, calculator work is important. Compute all in one. Now let us use calculator. You can do all in one. 37 minus 6 times 13 divided by 2 is equal to negative 2. Divide by square root of 6 times 13 divided by 12 close bracket equal to, so your test statistic is negative 0.32. If you use the class 2W 41, 41, then 41 minus N1, this time N1 is class 2 size, 6 times 13 divided by 2 is equal to 2, divided by square root of 6 times 13 divided by 12 close bracket is equal to positive by 32. Positive and negative only different. Now your test statistic is not in the rejection region. This is not very far from 0. Maybe this is negative 0.32. This is in the middle, near to 0, then critical values. Therefore, you cannot reject HO. Now you check the answers.